Okay, we're going to look at practice F, kinetic energy in perfectly elastic collisions, and we'll do number 1 together. It says a 0.25 kilogram arrow so we're going to call that MA. Again, if you want to call things 1 and 2, that's up to you. If you want to use a double subscript, that's up to you. I prefer most of the time to use letters and then prime. A 0.25 kilogram arrow with a velocity of 12 meters per second to the west. Now, this is the point I need to be aware of my sign convention, because we know that momentum is a vector quantity. It has both magnitude and direction. So I'm going to call west negative because I'm going to use my standard Cartesian sign convention. Up and to the right is positive, and we have north, south, east, west, so I'm going to call west negative. So this is going to be negative 12 meters per second. Strikes and pierces the center of a 6.8 kilogram target. So MB is equal to 6.8 kilograms. Find what is A, the final velocity of the combined mass. Now, first we're going to think about this. If I have an arrow and it's moving along and then it hits a target, the arrow is embedded in the target, so they move together as one combined mass. So my final velocity is going to be V prime. B, what is the decrease in the kinetic energy during the collision? So I actually want to find the change in the kinetic energy. And that's it. So for part A, I know that the two masses are separate, MAVA plus MBVB. This is the total momentum before. That's momentum of A and B. And remember, momentum is mass times velocity. And then that's going to be equal to the combined mass, MA plus MB, times V prime. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So V prime is equal to MAVA plus MBVB over MA plus MB. So now I'll substitute in my values. I have to be careful with my sign convention. Negative 12 plus 6.8. Now remember that initially the target is at rest because the target isn't moving. Now they don't tell you the target's at rest. You might think, oh, I'm missing some information. But then as you think about it conceptually, you're going to say, oh, the target's not moving. Divided by 0.25 plus 6.8. So V prime comes out to be negative 0.43 meters per second. But the negative sign means something. The negative sign, according to my sign convention, means it's to the west, while my final answer is V prime is equal to 0.43 meters per second west. And that's my final answer. So again, I always need to make sure I'm aware of my sign convention. I need to establish my sign convention in the beginning because momentum is a vector quantity and it has both magnitude and direction. And then when I put my final answer has to have both magnitude and direction. All right, let's look at part B. So part B says find the change in kinetic energy. So change is the symbol delta. We want to find the change in the kinetic energy. And the change in the kinetic energy would be the final minus the initial. Well, what is kinetic energy? Well, I know kinetic energy is 1/2 mv squared. So I could either do this as one long line, or I could do it separate. What I'll do is I'll just do it separate so I don't make a mistake. So first I'll calculate KEI. So KEI is 1/2 MAVA squared plus 1/2 MBVB squared. So the kinetic energy before is the sum of the kinetic energy of object A and the kinetic energy of object B. So that's going to be 1/2 times 0.25 times negative 12 squared plus 1/2. Now the target's at rest, so it's 0 squared. But I just wrote it out. So KEI comes out to be 18 joules. Then I'll find KEF. So KEF is equal to 1/2 object A, V prime squared, plus 1/2 MB, V prime squared. Now, of course, I could simplify that. So if you wanted, you could just have written it originally 1/2 MA plus MB times V prime squared. Okay? But it doesn't matter. Either way, when you write it, you're obviously going to get the same answer. Okay? And when you're doing it, if you think to do it separate, that's fine. If you know it's a combined mass, you do it like this, you're going to get the same answer. So when I substitute in my values, 1/2, 0.25 kilograms plus 6.8 kilograms times 0.43 meters per second squared, my final kinetic energy comes out to be 0.65 joules. And then my last step is I just go back to the beginning and I say delta KE is KES minus KEI, which would be 0.65 joules minus 18 joules. So delta KE is equal to negative 17.35 joules. So what does the negative sign mean? The negative sign means that it's decreasing by 17 joules because we did two significant figures. So that's really my final answer. It said, what is the change in the kinetic energy? So the change in the kinetic energy is that it decreases by 17 joules. Or change is actually absolute, so the change would be 17 joules. But in case you're asked, is it an increase or decrease? Okay. So that is practice F.